So are there any questions on 1, 2, or 3? All right. I don't want to spend too much time going over this because I think we're pretty strong with this right now. And you'll have some more practice with this later in class too. So again, I feel like I'm feeling okay about this. But again, if you have questions, let me know. So no questions here. I will point out one thing here. Number 2, right? No solution is a possibility. In this case, when we combined like terms and we distributed that 5, we had 10y on both sides here. And when you subtract 10y from both sides, you end up with this statement. Is negative 4 ever equal to negative 10? No. And so that means there's no solution here. Now, there are other situations. For example, sometimes you can get like negative 4 equals negative 4. Okay? And in that situation, it would be infinite solutions. Infinite solutions. Or if you got like 0 equals 0 or 10 equals 10. Infinite solutions there. Okay? That means any number you plug in will always solve the equation. Okay, but here, this is a never true, so there is no number. There's no number you can put in for y that will make both these sides equal. Okay? And then there's number 4. Combine like terms, get p over to one side and solve from there. Okay? Any further questions on 1, 2, or 3? All right. Then we're going to jump down here to then our application, some of these word problems. All right? And I want to take a little bit more time here as far as just like, breaking these things down. The problems already kind of break them down for us. Okay? Most of these problems start with A, having you just write the equation, and then identifying the variables too, and then B is the space where you solve. Okay? So let's read through this here. Number 1, Lisa is currently saving her earnings for a fancy calculator. She currently has $40 saved. Each week, Lisa will save an additional $5. If the calculator costs $135, how long will she need to save in order to afford the calculator? So there's our ultimate question we're trying to answer here. How long will she need to save? Okay? So, call on somebody here. All right? And I may end up calling people twice in a row or something like that. We'll just see how it goes here and stuff like that. But Alex, what is our unknown amount here according to the question? A number of what? How long? So that would be a number of what in this case? Weeks. So what variable would you like to use here? W. Sounds good to me. So let's let W equal number of weeks. All right. I'm going to pick somebody else, Alex, to write the equation for us here. So then, Simon, got an idea here about how you can set up this equation?
40 plus 5x equals 135.
40 plus the 5x, and we're going to use W, sorry, because that's what I had for the variable, but 5x for you would be fine there, equals 135. Perfect. Okay, she started with 40. Each week she saves an additional $5 per week, right, every week. And that's going to then, you want to know when that's going to equal 135. Okay? And that's the idea there. Great job. Okay, well done, Simon. All right, so we'll go to, let's see here. Mark then. Mark, we're going to rewrite it down here, and I'd like you to help us solve this.
First,
Subtract 40 from each side. Okay? So we're left with 5W there, right?
Yeah, equals,
and then I can do that subtraction for you if you want. 95. Okay, and then? Divide each side by 5, okay. And so then W is, and that would be 19, I think. And Mark, in this case, it's 19 what? Don't give him hints, folks. He's got to figure out for himself. You're not going to give him hints when it's quiz time. 19 weeks. And if you ever need help, remember, you can go right back up here. What did I say W was? Number of weeks. So it's 19 weeks.
Mr. Whitmire.
Yes.
Points off for not labeling?
It doesn't say in the directions that you need to label your answer, so I would be okay, but I prefer you to label it, though. I prefer labeling. Yeah. Okay. All right. Great job so far, folks. That was well done. Oh, did you need to see that? Are you good? Okay, so.
Any questions on that one?
Yeah. Are we, This one is similar to which one of our two problems we did in the warm-up? Which one is this similar to? Number one, right? Okay. Same kind of idea. In number one from the warm-up, we were given an initial height, a starting height, 450, and then we had a rate of change. It was descending at a rate of 20 I think it was like feet per second or something like that, feet per minute maybe, minute. Okay, and then we had a final height. Here, similar idea. We had a starting amount of money, we had a rate of change, how that money was changing over time, and then we had a final amount we were shooting for, right? So that's, you know, they're similar in that sense. They're not all going to be that way, but they're similar. Okay, next, the perimeter of a pig pen. That's a lot of P's. In the shape of a rectangle is 170 feet. The length is 5 feet less than the width. Okay, so let's go to Tyler C. So Tyler, what's our unknown quantity here? And it's kind of hard to tell because there's not a question kind of popping out from it, but you might, you know, we can still figure it out. What's an unknown quantity here? Unknown amount. Okay, and so, so we know the perimeter, right? We're told the perimeter here is 170 feet. What don't we know, though?
Like how much the length is.
Ah, very good. We don't know the length. What else don't we know? Besides the length, we also don't know the width. But we know they're related. The length is 5 feet less than the width. So we know a little bit about the length. The length is 5 feet less than the width, but we know nothing about the width. So what we're going to do is let W equal the width, okay, in feet, like that. So if W is the width, then what could I write to represent the length?
L.
We could use L, but we don't want to have two variables in our equation here. What else do we know about the length? How does the length relate to the width? And Tyler, I'm going to have you answer this one. How does the length relate to the width? The length is what?
5 feet less than the width.
So how could I use that? Write that as an expression.
4x
Sorry, that was too far. All I want to do is what was the width be in term? What would the length be in terms of the width? So the length is 5 feet less than the width. So what would that be? How would I write that? Yes. So we're going to use W in this case because that's what I have. So yeah, W take away 5. Exactly right. That's 5 feet less than the width. Okay.
So Tyler, did you write that down? Did you write these two, W is equal to and L is equal to? I asked Tyler because he was answering, but all of you, the question is, write the equation, you identify all the variables used.
Yes.
So part of test taking is to read the directions and to make sure that you put everything down so you can get full credit. Because this is like an easy part.
Right.
Don't forget to do this and
Right.
not get the points for it.
Right. And also, you know, don't get down on yourself if you're not understanding this stuff. If you can get this, that's showing some understanding, okay? The point is not always to get 100% right, okay? You guys are still learning this stuff. It's not like, you know, if you don't get 100%, that's okay. The point is to get better too. So if you're getting this down okay, hey, that's good. Let's try and get the rest of it too. You know, keep it up. Don't just be settled for this stuff, right? But Tyler, you are doing a great job so far. Now, last thing here, Tyler, what would be, the equation we could write here?
4x minus 10 equals 170.
Okay, so I'm going to use again the W's there. 4 minus 10 equals 170 feet. Now, Tyler felt confident enough to go ahead and jump right into writing that equation, but he did a lot of work up in his head for us to get to this point. So I want us to take one step back from what he did, because he's right. And that's great, okay? But I'm going to take one step back just for those of us that maybe are like, whoa, we have a W and a W minus 5. Where'd this come from? All right? In this case, since we're talking about a rectangle and we're talking about the perimeter and we're talking about length and width, what might be a good idea, an extra strategy to use here? What would be a good idea to use this space for right here? To maybe do what? What would be helpful?
I know what I did.
A good strategy here. Yeah, Tyler?
You can add up all variables and the 5.
Yeah, that's true. I was taking one step. Yeah, Matt, what do you want to?
Like the actual rectangle?
Yeah, like draw it. Okay, and so but we're going to get to that, Tyler. Yeah, again, Tyler, you've got this, and that's great. That's really good. Okay, but I just want to make sure we all get this picture down too. Okay, because I think it's helpful to draw a picture. It's a rectangle, right? And so I don't really care which one you call the width or the length. I'm going to call this the width right here, which means this is also W, and then I'll call this the length. Okay. And since we're talking about the perimeter, you find that by doing what with all the sides? Add them up. So this plus this plus this plus this. So Tyler, did all that in his head. He had this, and then he was able to get right to this, okay? And that's fine. If you can do that in your head, awesome. If you find yourself having some trouble, draw a picture to help you. Add up all the sides. W plus W plus W plus W, 4W, minus 5 to minus 5. They're like terms, they'll be minus 10, and then Tyler knew it was 170, okay? So, well done there, Tyler, and anyone else that was able to get that all together too. I'm more concerned that you can at least, though, if you need a picture, use it, okay, please. All right, let's go to then, Erica, you ready to solve this one for us? You want to help us out? How can we go from here? What should we do? What should be our first step? Add 10 to both sides. You got it. Well done. So we're left with what over here? 4W. And then 170 plus 10 is 180. And then what's our final step there? Divide both sides by?
180. No, 4.
You're right, because the 4 is with the W, so when you get that W by itself, good. Okay, and so that's going to be 45 then, okay? And we'll put that in feet. Okay? All right, and that's our answer, right? 45 feet? For width. Oh, see, Sky's on. I can't trick him. What else do we have to find here? The length. What is the length? W minus 5. So you got to make sure you're answering that question. And again, folks, I know I get a little silly. Maybe I'm even a little extra sometimes. But 40 feet, you want to make sure that you're answering all the questions that are being asked here, okay? Don't lose points because you're not reading and answering the questions, okay? Don't lose silly points. Okay. So there's your answer. All right. Ooh, we have a letter C for this one. A letter C. Let's go to Caden then. So Caden, I'm going to read the question and then see what you think here. If the area of a rectangle is found by multiplying the length and the width, we've heard that before, right? Find the area of this rectangle in square feet. Okay, so what should we do here to find the area of the rectangle? Pass. Okay. All right, how about Kendall? What do you say here, Kendall? What should we do to find the area of this rectangle? Yeah, exactly right. The area will just be 45 times 40. Okay, which if we do that here real quick, it's 1,800 feet square. Okay?
So question, did you all get from the question that they were giving you the formula for area, which was length times, I'm sure a lot of you know that, but did you see that was also, they shared that with you?
Yes, that was given in the words
this
there.
area, okay, so I don't know if that held anybody up, like area, I don't know how to find that. They told you in the problem, okay?
Mm-hmm. So feel free to use that information. All right, so we got that. Kendall, great job there. But we're not quite done yet because it said find the area of the rectangle in square feet. And then it says, what is the area of the pig pen in square yards? Square yards. So in order to find it in square yards, what do we need to do with the 45 and 40? This is 45 feet, and that's 40 feet. What do we need to do with these two numbers? Well, we did multiply them here, but before we multiply, what do you have to do to okay, yeah, divide by 3. Convert to yards. So I'm going to take that 45 feet, okay, and I'm going to convert by using the fact that, 3 feet is 1 yard, okay? So we're actually mixing together some dimensional analysis, unit conversion with our equation solving here. Okay, Sky can do it on the top of his head and just see, I know I need to divide by 3 here. However, if you're unsure, remember that 1 yard is 3 feet. Okay, we put the feet in the denominator here because we need the feet to cancel. And we'll be left with 45 divided by 3, which is 15 yards. And then I'll also convert the 40 as well in the same way. 1 yard is 3 feet. Feet will cancel. 40 divided by 3, I think, is 13.3 repeating, I believe. Yep, 13.3 repeating yards. Okay. Whew. So are we done now? No. What do we still have to do? Multiply them, because we got to find the area of the pig pen in square yards. So we'll multiply these two numbers now. 15 times 13.3 repeating. Okay. And you get 200. Now, here's a question I have for you. Okay? how many of you knew, first of all, that if you have feet, you can divide by 3 and that'll give you yards? How many of you guys knew that? Okay, a few of us did. That's fine. Okay, so if you look here, we took 45 feet, we took 40 yards. Sorry, we took 45 feet, we took 40 feet, and we converted that to yards by dividing by 3. Okay, you don't need to know that you divide by 3. Again, just use the dimensional analysis that we did. Okay. But if we can just convert from feet to yards by dividing by 3, why don't we just take our area here? Could we have taken our area and divided it by 3 to get our answer in terms of yards here? Would that work? Is 1,800 divided by 3 equal to 200?
No.
It's not. That's weird. To convert these feet into yards, we can divide those by 3. We can divide 45 by 3, we can divide 40 by 3, and we get these two. Okay? That's right. And we get this many yards squared. But if we take 1,800 and divide it by 3, we do not get 200, we get 600. That's not quite right. Okay? And there's a reason for that. Okay? There is a relationship there. I don't think I'm going to spend too much time going over it right now. You'll see it more in geometry class though too. But it has to do with the fact, it has to do with this. I'll give you like a quick, like a brief overview here for those of you that are, wondering about this. To get 1,800, we had to multiply the 45 and the 40. Okay? To convert these, we had to divide both of them by 3. So we had to divide by 3 twice. What are you really dividing by if you divide by 3 twice? Not 6. Close though. If you divide by 3 twice, what are you really dividing by?
9.
9. Yeah, you're really dividing by 9. What is 1,800 divided by 9? It's 200. Okay? So each of these numbers had to be divided by 3 to get to yards. That means this has to be divided by 3 twice, and then you get to 200, because there's 2 things that had to get converted. Okay? 2 things that had to be converted, and stuff like that. But you don't need to worry about that. You can just convert these individually and then re-multiply, and that'll be the answer too.
Is the test going to be multiple choice?
So the test will have some multiple choice on it, but it'll also have questions like these too. Okay? Multiple choice is nice because it's like, hey, if I'm not sure, at least I can at least get a shot at getting it right. But there's also bad because there's no partial credit. Okay? So it's either right or wrong. All right. Any questions further on number 2 there? We'll keep going. Number 3, Peter wants to purchase a blender that costs P dollars plus 6% sales tax. Okay, this is starting to sound like which problem from the warm-up? Number 2, yeah, right. One that Danny did, okay? So he wants to purchase a blender that costs P dollars plus 6% sales tax. His mother will contribute $30 to the purchase. Write an expression representing the amount Peter will pay for the blender. Okay, so this one's a little bit different here. Peter wants to purchase a blender that costs P dollars. So we already know the variable here. Okay, P is number of dollars. Okay. And his mother, there's a key difference about what this problem is asking for than what the previous problems were giving us. What are we asked to write here? Write a what? Expression. And that's good. You just need the word expression there. What's the difference between an expression and an equation? What does an equation have that an expression does not? Tyler?
An equation has the answer while an expression doesn't.
Right. There's no equal sign to something else. It's just an expression. So we're not going to be solving anything here because there's no equal sign. There's not going to be an equal sign. We're just going to write out an expression here. Okay? Write an expression to represent the amount Peter will pay for the blender. Okay? So if he's going to purchase this blender that costs P dollars, and we're going to have to add 6% sales tax, but then his mother is also going to contribute $30 to the purchase. Okay? So we have to count for all these things. So let's go to this here. Let's go to, I'm going to pick somebody here. All right. So how about, Sky? What do you think here? Let's just come up with how much is the blender going to cost again? P. But then we have to add sales tax to that. So we'll say plus and then what? 0.06p. That's exactly right. But then his mom's going to contribute $30, so how does that affect how much he's going to pay? Subtract 30. You got it. Good job. Okay? So the price plus the tax minus what his mom is helping out with, so that's like the less amount of money that he has to spend. Okay? You can leave it like this if you want to. Okay? Or let's go to Catherine. Are there any like terms we can combine here that you see?
P and 0.06p.
Yeah, and what number's in front of this p right here that we could write?
1.
1. So I'll do 1 plus 0.06, which is 1.06p minus 30. And this is another way to write it. It doesn't say you need to simplify it, so either one is okay there. Okay. If it says expression, folks, no equal signs, right? No solving is necessary. We're just writing expression there. All right, so that's a little bit easier. Okay, let's turn on to the next page here. Bob is comparing 2 job offers. The first with Stieber Co. pays an initial salary of $45,000 with a raise of $1,500 each year. The second with Mr. Mills Inc. pays an initial salary of $39,000 with a raise of $2,500 each year. After how many years will the 2 salaries be equal? So we're going to write an equation here, right? All right. So let's go to Caden. Caden, what's our unknown amount here? What's our question? How the number of what? Pass? All right. How about Liv? What do you say? What's the number of what are we trying to find here? After how many years? We're trying to find a number of years here. So y is equal to years. We'll use y. Okay. Very good. All right. And then, Liv, do you want to help us write one of the equations here? Let's do the Stieber Co. one. So what would be like the expression? What would be the math that we're going to write for the Stieber Co.? An initial salary of $45,000 with a raise of $1,005 each year. So how could I write that out? 45,000 plus 1,500. Remember, that's per year, though, so we should put 1,500, or, yeah, in this case, I'm going to use y, since that's what I wrote. But you can use an x if you want to. Good. Okay? And we want to know, after how many years will the 2 salaries be equal? So we're going to set that equal to, then, the other salary, and we're going to pick somebody else here. Oh, someone who's here. How about Sean, then? Sean, what about for Mr. Mills, Inc.? What would be the equation for that? Starts there. Or the expression for that, I should say. Pays an initial salary of $39,000 with a raise of $2,500 each year. So what would he write for that? Pass. Oh, no. You're breaking my heart. All right, let's go to Matt S. What do you say?
Wait, can you repeat the question?
Sure. So we've got 2 companies here that we're trying to compare. The first one, Liv, gave us the equation. She said since we got paid initially, or starting with $45,000 and a raise of $1,500 each year, the equation should be, or the expression should be $45,000 plus $1,500. Why? So far, so good? Then for Mr. Mills, these are our information. $39,000 to start, initial salary, and then a raise of $2,500 each year. So how can I put that then in the math? 2,500. What's the variable? Y for this case, yeah. All right, Sean, does that make sense? All right, we're not doing anything calculation in the calculator right now. You might want to be focusing up here to make sure you can, get this stuff down, okay? All right. I know the calculators are fun to play around with, but I promise I won't be asking calculator questions on the quiz on Thursday. I want you to be ready for that. Okay? So we've got our equation. We're going to solve it. Let's go to, and thank you, Matt. Well done, sir. Let's go to Reagan. Okay, Reagan, can you help us solve this here? I'll zoom in some.
Yeah, so you do 1,500, and then you can do that to 2,500.
So you want to, what do you want to do? When you say do, you want to like?
Oh, subtract.
Subtract. Okay, subtract. Now, some of you maybe would do something else first, and that's okay. There are different ways to start here. Reagan's way is not wrong. We can go this way, and you can go your way. Hopefully, you're picking a good one, too. So let's see, when I subtract, that'll be 1,000y. Okay, Reggie, you want to keep going here? What's the next step?
Yeah, I accidentally wrote the column down wrong, so I'm trying to rewrite it.
Okay, well you can, if you want, you can just tell me what to do and I'll do it and then you can copy down afterwards, or if you want to get caught up, that's fine.
Okay. And then where are we? You can do. Actually, I'll pass on that.
You're not sure?
I think I know.
Well, say it, let's just say it and just see what happens, please.
Okay, so
Be brave.
39,000.
So, okay.
Subtract that with the 45,000.
Yeah, see, you knew what you were doing. You knew what you were doing. Okay, good job. 6,000 is equal to 1,000y. And if you get something wrong, Reagan, it's okay too. We're not here to we're here to learn, okay? So I'm not gonna get mad at you or anything like that. Okay, anyway, keep going. What's the next step?
And then divide 1,000 with those.
Yep, you got it. Good job. Y equals 6. 6 years. Okay. So after 6 years, they'll be the same. Now, let me just take a little sidestep here, right? If you're Bob and you're trying to compare these two companies, you don't really care about when they're going to be equal. You really are going to care about how much money am I going to make? Which one's going to give me the better opportunity kind of thing. So you might be considering well, after 6 years they'll be equal, but what if I work for less than 6 years? Which one's better or not? Or what if I plan on working for more than 6 years? Which one will be better or not? And those are questions we'll look at later too, okay? So right now we're just worried about when they're equal, but later we'll be able to determine, which one will be the better choice, depending on what you're gonna do. And these are questions that you can, use math to help you answer when you're in your own life and trying to determine about what kind of job you wanna do, okay? All right, let's move on to the next one here. Number 5, Lorenzo buys 3 shirts at X dollars a piece and 2 pairs of pants at P dollars a pair. What does the expression 3x plus 2p represent? So here, we're not trying to write an equation. We're not trying to solve an equation. We're not trying to write an expression. We're just trying to interpret what this means. That's it, okay? So, Catherine, do you have an idea? What does this 3x plus 2p represent?
Total cost of shirt and pants.
Boom, that's it. Total cost of shirt and pants. You got it, Catherine. Great job. I'll say shirts and pants. Awesome. Okay. That one's pretty straightforward. I don't know. Any questions on that one? All right. Next. Timmy is 6 feet tall and has a shadow of 24 inches. At the same time, a building casts a shadow that is 76 inches long. Find the height of the building. Now, we haven't done a problem like this. We've done problems that, well, you'll see here. The setup is a little bit strange here. Not strange, but it's I think the setup where I didn't give you guys enough practice with this kind of thing. But we have talked about how to solve it. We're not sure how to set it up just yet. That's going to be the trick here. Does anyone have an idea about how to set this up? Yeah, Ben?
You'd have to start with 6/24.
Yes.
You could do, no.
Yeah, you're right. 6/24, and that's going to equal.
Simplify it though, right? To 3/12.
You can, but we don't need to worry about simplifying it right now. That's okay, just setting it up that way. So this is Timmy, this is Timmy, and then his shadow, right? And then what's that? What are we going to set that equal to? What's the other kind of ratio we can come up with there?
X over 76.
Yeah, there it is. Good job. So you remember from another math class maybe how to do that, okay? That's very good. And that is the actual building over the building shadow, okay? Now, we did not spend time setting these up, but we do know how to solve these. How do we solve these, folks? What do we do now at this point? Cross multiply is just the technique we want to use there, okay? So I'll do that real quick, and then we'll talk about the setup again because I want to make sure you're all okay with that. Okay, and then divide both sides by 24. So x equals 19. Okay, so 19, and that would be feet for the building there. Okay. All right, so Timmy and his shadow create a ratio. Okay, Timmy and his shadow create a ratio. 6 feet tall, and the actual height of Timmy, 24-inch length of his shadow. The building, if it's at the same time of day, why is it important that it's at the same time of day? Shadows change, right, exactly. Lengthen or shorten kind of thing. So it's important you do it at the same time of day. But if Timmy is 6 feet tall and his shadow is 24 inches, then you can measure the building shadow at 76 inches to use that to then determine the height of the actual building without, actually measuring the building. This is a technique called indirect measurement, right? Direct measurement is like when you literally take a, measuring tape and you're like, that's 3 feet, kind of thing. But indirect is when you use stuff like this, okay? So we set up a ratio for his height in the shadow to the building's height, which we didn't know, over its shadow, 76. Okay? Then you cross multiply and solve. You get your answer. Okay? All right. So that's the idea for that one. All right, on to the back. We've got 2 more questions. We're almost there, and then I'll let you guys get started on your own here. All right. Conversion, or dimensional analysis, right? Another way we say it here. 3 brothers were having a debate over which of their favorite animals was the fastest. Mark loves cheetahs and knew that they can run 75 miles per hour. That's pretty fast. Brian's favorite animal is the black marlin, which swims at a speed of 130 kilometers per hour. Beckham argued that the peregrine falcon is the fastest animal, flying up to 108 meters per second. Which brother's favorite animal really is the fastest? What's the problem with us trying to compare these 3 animals and their speeds? What's the problem here that we're running into? Ben?
They're different. Terms.
Yeah, different terms, different units, different rates. Okay, so you're like, wow, the biggest number we see here is 130, but that's in kilometers per hour. 75 miles per hour, well, miles are longer than kilometers, so maybe the 75 is faster. And then here it's meters, but this is in seconds, whereas these were both in hours. And so...
Also, that's not right. I don't think a cheetah can go 75.
I think go up to it.
It's 30.
30? Oh, no, I think it can go more than 30, I think. I think it can go up to like 70 or so.
No, I didn't know that.
So, and if you guys actually know your biology, if you know your, I guess biology, or if you know your animals, the correct answer you don't need to like necessarily. I mean, anyway.
I mean, like, it's not like you can run at sustained speed of 45 miles.
Correct, but it can reach a top speed up. Mm-hmm. Yep. So yeah, what do we have to do then? If they're all in different units, what do we need to do? Convert. Do we need to convert all 3? No, because we don't need to. If we convert all 3, then we might convert into completely different units. So we want to pick a unit to go with here. And so you kind of have a choice here about how you want to convert things. Okay? You can convert kind of however you want. What would you prefer here to convert to? Miles per hour, you're thinking? Miles per hour? Okay, let's do that. So, well, we don't need to convert the cheetah then. It's good to go. So we'll just leave the cheetah 75 miles per hour. Okay, so that's for the cheetah. All right, now let's look at then the black marlin, which is 130 kilometers per 1 hour. Okay? So, is it okay that we are in kilometers for this unit? Is it okay that we're in kilometers? If we want to compare it to miles per hour, is it okay we're in kilometers? No. No, what do we need? Miles. Is it okay that we're in hours? Yes, because we're in hours here. So all we have to convert is what to what?
Kilometers to miles.
Kilometers to miles, exactly right. Okay, so is there a conversion up here for kilometers and miles? Let's see here. There is. Okay, what is it?
1 mile equals 1.61.
That's right. So we'll multiply here. We'll put the 1.61 kilometers in the denominator because it's going to cancel with the kilometers in the numerator there. And then 1 mile. Okay, kilometers cancel. Do we need to do any more converting? Are we in miles per hour yet? What will our top unit be? What? What's our top unit going to be here, folks? Miles. What's our bottom unit going to be? Hours. We're good. We're done. We just have to multiply it out. So 130 times 1 is 130 miles. And then 1 times 1.61 is 1.61 hours. Okay, and then the only thing I'm going to do now is actually do the division here. 130 divided by 1.61. And it's about 80.7 miles per hour. Okay, bless you. And that's for the black marlin. Okay?
What's it for?
Black marlin.
Is that a
Okay.
fish?
It's the fish. Yep.
Then it's not animal, who's out.
What's that?
It's not animal, it's out.
That's right. No animals. Yeah, we're not going to talk about non-animals here. Okay, last one. We have to convert 108 meters per second into miles per hour. All right. Let's maybe focus on seconds first. So how can we get from seconds to hours? What do we have to convert to first? Let's go to Denny. Minutes. Okay. So how many seconds are in a minute? 60. So we'll do 60 seconds on top here, and then 1 minute on the bottom. I put seconds on top because the seconds were on the bottom here. We need them to cancel, so cross them out. All right, and then Danny, how about minutes and hours? How are they related?
60 minutes an hour.
You got it. Very good, sir. 60 minutes over 1 hour. Minutes cancel. Okay, great. We're in hours. But now what do we have to do? These are in meters, by the way. So meters to... Yeah, we could do meters to feet. You want to do that? That sounds good. Do we have a meters to feet? We do. Meters to feet. Okay, so let's do that. So meters, let's see here. 1 meter on the bottom is 3.28 feet. Okay, so the meters cancel. And then how do we convert feet to miles? How many feet are in a mile? 5,280. 5,280 feet. And again, I'm putting the feet on the bottom so we can cancel the units out there. And that's in 1 mile. Okay. So let's see here. 108 times 60 times 60 times 3.28. I get a really big number there. I guess I'll write it out. 1275264. That's in miles per, and then I'm going to have to divide by 5,280. And that's in hours. Okay. And I get 241.5 miles per hour. And that's for the peregrine falcon. Okay. So, which brother is right? Which brother is right here? Beckham. Beckham, whoops, is right. Okay, the falcon is the fastest. What's the fastest animal on Earth? Peregrine falcon. Peregrine falcon. Fastest land animal? Cheetah. Fastest land animal? Cheetah. Fastest water animal, black marlin. Fastest animal, peregrine falcon. Okay? This is like the legitimate, like it's like approximately the legitimate speed a peregrine falcon can reach. Okay? 241.5 miles per hour. Pretty crazy. Okay?
So, question about test responses here.
Correct.
So, it says, which brother's favorite animal is really the fastest? Well, Beckham's is. Explain or justify your reasoning mathematically. Well, we explained and justified it mathematically.
Yes. Yes.
So the words just need to be the falcon is the fastest.
Right. Or you can just say the falcon is the fastest. That's enough. You don't need to say Beckham is right because it really just says which animal is right. Okay? That's fine. And then, yes, your work is your justification. You don't need to explain any more beyond that. Okay? All right, last one here, folks. We're almost done. A waiter at Super Big Burger tells you that today's special is for their 73-ounce Mega Stack. How many pounds is the Mega Stack burger? Okay, so 73 ounces. What do we need to do with that quantity? If we want to get it in terms of pounds, we have to convert, right? So 73 ounces over 1. How are ounces and pounds related? 16 ounces in a pound. Okay. Be careful, though, if you're out in the grocery store and stuff like that. There's fluid ounces, too. Remember, that's a volume, not a weight. So 73 divided by 16 here, 4.56 up. What's the answer? C. You got it. 4.56 lbs. All right, we made it, folks. So that was the review. Now, guess what? I have a B for you to try for yourself.
Yay!
I know. Wow, you guys, I love the enthusiasm. All right, let's keep this going. Okay.
This is our homework.
I would like to work on this again. I don't want to say it's homework, but please work on it for the remainder of class. You can jump around. I know I'm too easy, Miss
You are
Mulcahy.
so easy. Yes, it's
easy.
homework.
Okay.
Yes.
No, it's not.
Look.
Right, so, right. See, you already got started. Look at you. Lucky duck. All right, here we go. Okay. While we're together, feel free to jump around if you need to on the paper, I mean. So what I mean is you don't need to start number one. If you're like, man, I really feel like I got those equations, I would suggest you hold on to it so you can refer to it if you need some help. This is another view. It's very similar.
No, it's not.
Pretty much. If you feel like you know, it's not very easy for you to get through.
Oh, no, they're not gonna do it.
Matthew, please.
If they do, I'm just
Burn.
Okay.
So I'm set with that.
Yes, we have a good 15 minutes. We have a good 15 minutes to get started.